We're going to discuss Kotlin, and we're going to talk about what is that unsafe world. So to start off, let's talk about what is type safety. So it is kind of confusing. When I thought of the title for this talk, I thought it was much less confusing than it was, but as I did some research, I found out, well, there's actually quite a few different ideas of what type safety is, depending on if you're looking at type safety in an academic world or type safety in a more practical, non-academic setting. So I want to start off by talking about kind of what is type safety to me, just so we're all using the same language. So well-typed programs cannot go wrong. This is a quote from Robin Milner in A Theory of Type Polymorphism in Programming. From my research, this is about where type safety started to pick up steam. It started to become an actual thing that people were talking about. So that's the quote that I'm going off of for the rest of the definition of type safety. So to break this down a little bit, let's first talk about what does go wrong mean. So this is a C program. It is defining an array as character buffer. It has a size of 9. And then on line 3, we are overwriting some place that we don't have control over because the 9th element, it's not valid here. And so C allows you to do this, but C does not define what that behavior is. It could cause the application to crash. It could overwrite memory that is currently being used and cause the system to go unstable. So going wrong, we can think of it as something that is syntactically valid. You can write it. It'll allow you to do that. But for C developers, they would look at this and think, well, that's either meaningless or that's going to be really buggy. So an example of what this might look like in Kotlin and why Kotlin, we can say it is type safe, is you can still define an array. You can still write past the array. But before that happens, the language itself will actually catch that. And then it'll throw an exception, an array index out of bounds exception. And that's actually defined as a part of the language. So we can say that because this exists, Kotlin has defined that behavior. At least for this portion of it, it's a type safe language. One more example of this is for Ruby. You can actually call a method on an object where that method isn't defined. And Ruby allows for this. It's a part of the language. If you try to do it, so in this example on line 1, we're calling Cody is great on a string, but the string doesn't define that method. So it'll throw a undefined method exception. And because it defines that, because you can do this and the application won't do something undefined, we can also say that Ruby is type safe. So in terms of type safety, I've come to the conclusion that some languages have stricter behavior than others. It doesn't necessarily mean that one language is more type safe than another. It just means that they define their behavior a little bit differently. As long as they're not allowing you to do actual undefined behavior and cause unexpected things to happen, we can say it's still type safe. So going on to the next part. So what is Kotlin? So it is a pretty strict language, but it's also concise. And so we'll go through some code snippets real quick for that. So Kotlin allows you to define types. In this example on line 2, we are defining a string that is set equal to Michael. The name of it is name, so we're defining someone's name. On line 4, we do print line, so it will print out hello Michael. Now, even though Michael is type string, because we're defining the actual string where it's being defined at, we don't actually have to include the type of it. Kotlin will infer the type. So it keeps it being a strict language, but it's also concise in the fact that you don't have to always provide the type. Kotlin also allows you to define mutability. So in the previous slide, we had val name. That was a immutable name. Once it is set, you cannot change it. In this example, we have a var, which says that the name is mutable. So it's being defined as a string still, but we can change it to the name afterwards to Cody. So we can say, hello, Cody. Another example where you can define structures in Kotlin, that's done through the use of the data keyword. So we have a data class of name. So on line 2, we have the first name, we have middle name, we have last name. And then looking at where it's actually being used, on line 8, we're just defining name to be equal to Michael Watson. We're just using named parameters to say first name is Michael, last name is Watson. And then we print out the name, hello, Michael, by doing hello, and then name.first. The final thing that we'll actually go into with Kotlin is you can also define nullability. This is a pretty big part of the language itself. So looking at the name class, we have the first name being defined as a non-null string. And then on line 5, we have the middle name being defined as a nullable string. And that's by adding the question mark to the end. So Kotlin actually breaks up non-null and nullable types in its type system, and it allows you to do a lot of really neat things that we'll get to a little bit later on in this talk. The final thing that I'm going to gloss over real quick, but if you are really interested in Kotlin, it would be weird for me to not call this out. You can actually define concurrency in Kotlin as well using coroutines. So here's a quick snippet, but we're not going to get into that. That's not super pertinent to this talk, but I just wanted to call that out really quick. All right, so we went over Kotlin. So now let's talk about what is the unsafe world, and that would be our APIs, because largely they're written in JSON. And this example is from a previous company that I worked at, not PayPal. Not going to say the name of the company, but we had a API that was a little bit flaky in terms of how it was defined. So let's get into that. So we have a permissions API where the response is admin, and it returns a Boolean. So you're probably thinking right now, well, Cody, that's perfectly fine. It's a Boolean, like that is what it should be. And you would be correct. If this was actually how it was defined, I would not be giving this talk today. This is actually how we ended up modeling it on the client side. And so we'll look at that, and then we'll actually go into how the response was modeled. So in Kotlin, we had a data class called permissions. We had a property called isAdmin. It was set to a Boolean. And then on line 5, if we wanted to create that locally, we would just do permissions and then pass in the value of true. So if this was the case, everything would be great. Getting into an example of what the API looked like, it would actually return a numeric value instead of a Boolean. So this isn't too bad. I can see the rationale in terms of why you would want to do this. So when you think of Booleans, you think of 0 and 1. The downside is there's also -1 to -infinity, and then 2 to infinity. And so a number isn't really a Boolean, but I can see the rationale. This isn't the end of the world. And actually the way that we accomplished that in Kotlin is we created a extension function on the int class that returned a Boolean. And then we just checked, is the integer not equal to 0? And so as long as you passed in anything that wasn't 0, it would return true. There's some pros and cons to that, but that's how we had that modeled. And so in this example on line 6, you can see 1.2 Boolean. We'll convert that over to a Boolean for us, and it should return true. The next example, and kind of where this API got a little bit wonky, is it could also return string values. And the string values that it would return are numeric values. And so we have isAdmin is equal to the number 1 as a string. And so this isn't great, but I was pretty excited to be able to use extension functions even more. And so the solution ended up changing a little bit. So with the code snippet that we're looking at right now, we had to go from toBoolean to asBoolean in terms of the name, because the string class already defines a function called toBoolean. Unfortunately, it converts the Boolean literal of true or false instead of the string value of 0 and 1. So we couldn't use it there, but we updated the name to asBoolean. Instead of making this an extension on int, we made it an extension on any. So any class, any type could be invoked with the asBoolean function. And then we kept our integer check the same. So if it is an integer, we do the same thing. On line 4, if it is a string, we just convert it over to an int using the strings toInt function. And then we convert it to the Boolean using the asBoolean function. Otherwise, if it's not an int, it's not a string, we just return false. And so in this example, we have 1, and then asBoolean will return the permissions for an admin. All right, so next up, I can't really recall if this was a thing. I think it was a thing, but it's hard to remember. But I'm pretty sure there was a point in time where I saw this API also return the string literal of true. This wasn't too bad. The solution itself, you'll see on line 4 through 7, we made some minor updates where instead of always just converting it to an int. We're using toInt or null on the string. And so what that'll do is if the integer, or if the string itself is not a valid integer, it will return null. And so we can take advantage of nullability being built into Kotlin's type system. For that, we convert it to a Boolean if it is an int. If it's not an int, then we will call toBoolean, which will call the strings toBoolean function, which will return true or false depending on if the string is true or false. All right, so the last example is the permissions could also return null. It wouldn't return null for a permission that was already existing, but if we were adding a new permission and that permission hadn't been seeded yet, it would return null. And so this actually was really simple to integrate. So all we had to do is on line 1, we modified the extension function being on a non-null any to be on a nullable any. And then for the typecasting and going through checking the type system, well, if it is null, on line 3, it can't be a non-null int. On line 4, it can't be a non-null string. And so it'll fall through to the else section where it is a null value, it returns false. And you'll see on line 13, we can pass in null dot as Boolean, and then that'll work perfectly fine. All right, so I just want to wrap up this talk by saying, kind of calling out how we can make the world a safer place by designing safer APIs. I think the previous talk that we just saw was really helpful. And so, yeah, let's get into it. So the first thing is stick to a strict API when rolling your own specification. So if it's going to return a true or false value, just use Boolean. Try and be really strict with that. Alternatively, though, if you can use an industry standard specification such as OpenAPI, that's even better. It's already defined. You can get some really neat code gen with it as well. So that would be another really great next step for making your APIs even more usable. And then the last one, you can also look at JSON alternatives such as protocol buffers. So you don't have to just think about using JSON. You can use protocol buffers, which will generate code for you as well, but it also uses binary serialization. So it'll actually run a little bit quicker than using JSON, which is more human readable. And so that is all I have. I wanted to say thank you to everyone. If you want to learn more about Kotlin, I have a YouTube channel, bit.ly/Cody-YT. That has a bunch of Kotlin tutorials on it. You can also connect with me on Twitter, and I've also written a lot of stuff on Medium. So if there's any questions after this, please feel free to reach out to me on Twitter. But otherwise, thank you so much for having me.